Good afternoon, everyone. My name is Hema Baboolal, and my research is characterization and spatiotemporal distribution and modeling of air pollutants along Trinidad's west coast. This project was supported through funding via a BPTT fellowship, and it's done through the UTT under the Environmental Studies program. My dear supervisors are the most loved Prof. Valerie Stout and the well-known Dr. Valadin. Let's do the steel-fashioned way. All right. Now, air quality at any given location is affected by a large number of factors, including time. What I've done is pictorially shown you all the different things that can affect air quality. Contaminants in the air, if they get advected or convected or through convection sent into the stratosphere, one of the phenomena that's well known is degradation of the ozone layer caused by CFCs, for example, getting into the stratosphere and affecting the equilibrium of ozone formation and making this, and the effect is that it decreases the amount of ozone, therefore letting more harmful UV radiation get into the troposphere. Troposphere is the first 5 kilometers or so of atmosphere where most human activities take place. Pollutants that get high up in the troposphere, they can get transported through long distances. For example, a natural pollutant, Sahara dust. We are experiencing that now. Sahara dust comes all the way from Africa across the Atlantic Ocean, affects the whole Caribbean area, and that's transboundary pollution. In the boundary layer, which is one where most of us exist, where most human activities take place, air quality can be affected by natural things such as flatulence from cows in fields that we can do nothing about. So these are natural, but there's also the anthropogenic, which is something we can do something about, that the man-made pollution that comes from vehicular emissions when vehicles are idling on roadways, from fugitive and point source emissions from industrial sites, from exhaust fumes from boats and trucks, and from burning on the dump, as you experienced earlier this week, from bushfires. All these contribute to affecting air quality and to contaminants in the air. Now, air pollution is serious business. And why we should take it seriously is this: air pollutants are implicated in bringing about some of the atypical weather patterns that we see on a global scale. Atypical weather patterns associated with changing tidal formations. They are greenhouse gases. Greenhouse gases are the cause. They are air pollutants. Property damage caused from acid rain. Acid rain, when acidic gases get into the upper atmosphere, they coalesce with the water particles. What goes up must come down, comes back down as rain, so it's deposited, comes down as acid rain, which can erode buildings, damage crops, example. Air pollutants also cause harm to human health. There is research, conclusive research, that points to air pollution causing increases in 2 categories: increases in the deaths due to cardiovascular disease and to lung cancer. However, most of the effects of air pollution tend to be chronic. They cause asthma and respiratory illness in sometimes otherwise healthy people. So it doesn't just exacerbate the respiratory illness and asthma-prone people, it induces the disease. Last year, WHO published a report where it was reported that air pollutants was the single largest environmental cause for global deaths, alluding over 7 million people have died as a direct result of bad air quality. So it's not a joking thing, and this is not news. Most industrialized countries have had air monitoring programs and have been monitoring their air quality since the 1970s, 1980s. A lot of developing countries are now on board with this. So we're kind of late in the game because we just passed our air pollution rules, and we can't even begin to, I'm going to say this a few times, we can't begin to manage what we don't measure. Right. This data, don't get scared, the data is a plot of The EMA has set up 2 air quality stations, which were set up at Point Lisas. This represents the only long-standing continuous air quality data we have for anywhere in Trinidad. This is a plot of January to December 2012, and the flat lines, and I've used this theme throughout the other graph that you will see later on in the presentation. The flat lines are the limit values as quoted in the Air Pollution Rules 2014, and the dots and the jaggedy lines are the actual measured values or calculated values. What it does show is that there are, at least for this monitoring site where it's circled, the pollutant levels were at least very close to the limit values, which are values that they should not exceed, or have exceeded them. So it does point to we have a problem with greenhouse gases, we have a problem with other parameters that affect public health. Okay, so that's the background information. In the 1980s, Point Lisas industrial development took place, which was Point Lisas is the cradle of industrial development, to coin a phrase that my professor taught me yesterday. It has brought the boom that has happened, transformed Trinidad's plantation economy into an industrialized economy, so much so that we are now one of the most industrialized we are the most industrialized of the Caribbean islands. We have world-scale industries. We are the #1 producer of ammonia and methanol. We are a gas and oil producer, a major oil and gas producer. Not oil and gas anymore, it's gas and oil. We use a lot of energy for a lot of these industries. Recent estimates, I think this was last year, and from Donnie Buzlal's work using IPCC 2006 calculations, Tier 2 calculations, it indicated that both for GDP and per capita, we rank #2 in the world for the amount of greenhouse gas we produce. Which means that if we were a bigger country, we would probably be recognized. But because we're a little country with a little population, and we're not that significant in terms of the total number. But it is really bad for us because it's the rate that counts. If there were more of us, we would be polluting more, which means we're wasting a lot of energy and polluting quite a lot. So this comes to my research question. My research would like to answer, and is centered around answering these 3 questions. What are the typical chemical constituents of the air pollution on the West Coast? Now, there are 7 criteria pollutants, but we don't only have 7 pollutants in our air. We have a myriad of pollutants. We need to know what they are before we can even try to see where we can target to manage. How much of each pollutant is there? Does the pollutant distribution change with time and space? And if so, how does it? These questions will be answered in 5 objectives, which I've set out to achieve in this project. And I'm going to read these out because it's very important. The first one is to partner with stakeholders, because there is a lot of work to be done. There's a lot of work that's already been done. It was necessary to collate historical databases for weather patterns, for air pollution data, such as the EMA long-standing database from 2004, as well as to get data. Well, I had to get geospatial data, because there's no need to reinvent the wheel if geospatial data already exists. When you have to do mapping and plotting and analyzing in GIS, you do have to use spatial data. There is a field sampling regime, which will extend for over 12 to 18 months to sample both gases and particulates at 4 representative locations, representative of a rural, urban, industrial, and a kind of mixed land use areas. These would be done every 60 for a period of at least 12 to 18 months. There will also be measurements made at landfill, representative measurements made at landfills and roadways to be able to put this into some kind of digital format. Hi. The third objective of the project is for spatiotemporal modeling using a regulatory model, an acceptable regulatory model. USCPA AMOD is the one I chose. And the 4th one is to compile all this data into a GIS to make it readily usable to anybody who needs to use it for air quality management, to set a baseline so that it can be used as a reference for environmental impact assessments in the future, and on which to start an air pollution management strategy. And the 5th one is the most important. The results from this project are not intended to be bound in a thesis and sit on a shelf. It is required that it be used for national development. That's the stipulation of the fellowship, and I will do my very best to work with stakeholders, anybody who would work with me, to share the information to build on it, because this should just be a starting point. This is just a map to show you where the location of the stations are. My urban station is Port of Spain, and 3 of them are located on UCT campuses, and 1 not. The John D campus in Port of Spain is my urban station. The rural station is at UCT Waterloo. My mixed land use station is at SFTI in San Fernando. And my industrial site is located on the Caroni Limited lands, Sucrocan Limited, which is the company just just adjacent and south of the Port Lisas Industrial Estate. And there's a story to go with that, and I'll tell you later in the presentation. The methodology, basically 4 steps: collection of data to inform literature review, to inform how I went about collecting field data, and to lay the basis for all the inputs I need for modeling. The primary data collection is the field regime. It's very expensive equipment. It's very expensive to collect air quality data. It's also quite labor intensive because these locations are located along the west coast of Trinidad. I have to go to each one of them, set up safe sample stations, pick them up. It's a lot of time and effort spent doing that. The modeling is necessary because I can't sample every 100 meters. It's expensive, it's impractical to do so. So you have to substitute with something that can represent all that's necessary and to fill the gaps. The modeling, however, requires a lot of data inputs. Hence the reason there was a lot of effort spent in accumulating historical and current weather patterns and pre-existing data, as well as point source or any ambient air quality data that was available from the EMA's public library. And the last bit of it is to integrate simulated and field data into a GIS so that we can have a spatial distribution map of pollutants for Trinidad, or at least for the west coast part of it. This is what my sample station, my sampling gear looks like. This is the particulate sampler. It's a German-made sampler. It's a combined head, low volume sampler. It collects particles. It collects over a 24-hour period a fixed rate of air influx into the particulate sampler, and size separates it into PM10s, 2.5s, and 1s. PM10, 2.5s, and 1s are called that because of the aerodynamic size of the particles. PM10s are particles that have an aerodynamic size of about 10 microns. PM 2.5s are those that have a size of about 2.5 microns, and so for 1. So it separates it out. This is done, all the particulate material that's filtered is collected on pre-desiccated and pre-weighed filters, which are inside the sampling head. And the differential for pre and post weight is what you calculate as your deposited material, your particulate levels. It is intended that this particulate material will be digested and analyzed using ICP-MS to get heavy metal content, trace metal content. So you could be able to get heavy metal content per cubic meter of air, as is represented in the air pollution rules. This is what my gas sampler looks like, this picture on the right. This is the GasMet DX4015 with its computer data logger, UPS, etc. It's kept in a cabinet because it can't get wet. There are certain limitations to the data. It uses Fourier transform infrared spectrometry to detect particles in the air. It can collect up to 50 gases at the same time and scan it against a library of about 350 gases. So it's possible to identify up to 350 different gases at this point in time with this instrument. The advantage of it is that it's passive, so it pulls in the air, analyzes it, and spits out data in real time, concentrations, identification of chemical concentrations, and it saves the spectral analysis so that for each 10 years later, if the technology gets better and we have a very detailed spectral picture of different chemicals, we can post-process it to see if it was actually present at this point in time. So it has some value for that. Okay, modeling. Modeling is required to fill the gaps where it is not practical to measure or it is too expensive to measure. I've chosen to use the US EPA AirMod model because it is widely used, one, and it's been used for quite a number of years. So the pros and the cons are well established. You know what you're getting into when you use this model. It's also, I think, the way that the EMA is going in its regulatory framework, so it was wise to put effort into working with something that can be used or likely to be used in the future. It does require a lot of data, and if rubbish goes in, rubbish will come out. So it requires data of a decent integrity to get reliable outputs. It is a steady state, so there is some mass balance in there. It does not consider loss due to chemical reaction, for example. Now this, as Prof said, this is current research. It's ongoing. It's just started. I'm only just about maybe 6 weeks into my sampling, having gone through, that includes a period of, how do you call it, baptism, when things will fail and things will work properly and you're learning how to do this and you're making this silly mistake, right, all of that. So I have some very preliminary data for you. The particulate levels that I measured at the stations, the urban and the mixed tended to usually be lower than the limit values, but on the industrial side, even though when you look at the filter, it looks nice and brown and not too heavy, it had the highest amount, it consistently had the highest amount of particulates. Particulates are important because it's directly, especially those below 10.5, they are termed the respirable particulates because they have health implications. Particles between 10 and 2.5 microns can be respired, but generally the smaller they are, the deeper they can be inhaled into the lungs. Particulates that are between 10 and 2.5 microns tend to be degradation products, direct result of direct emissions, like broken up tires and dust. Particles less than 2.5 microns tend to be gaseous species, acid species. For example, diesel fumes make up a large part of the PM 2.5s. And I've come across literature that quoted up to 43,000 different chemicals adsorbed onto diesel particles, which makes diesel particles really, really bad because PM 2.5s get inhaled wholesale into the human body and get deposited into the lungs and have negative effects. I would like to point out that if we were to do something about subsidies on diesel, the health impact might be a good justification for saying why they either introduce an environmental tax against the diesel, prices of diesel to lessen the burden that the government has to pay because it does cause a lot of environmental effect. It can be justified if you use that argument. Okay. The air quality profiles, the GasMet measures data in real time. So what I've done is kind of pulled out some of the data in plots for when I sampled. This is my rural station. And I want you to take note, I've used the same scheme, color scheme for all the plots, so it'll be easier to trace patterns if you memorize what they look like from one plot to the next. Just like the EMA plot earlier, the flat lines are the limit values, and the jaggedy lines or the dots are the measured values. I want you to take note of the ammonia levels, the ammonia that's present in the rural profiles and the mixed profiles. There's just some of it. And the NOx patterns, which is expected because NOx is a result of the combustion of petrochemicals. So you see this rural site. This rural site is located north of the industrial estate. You don't see it in San Fernando. You don't have that pattern in San Fernando. In San Fernando, SFTI, if you know it, is located in the middle of where all the highways are. So if it was just due to vehicular emissions, you would see a similar pattern. You don't see that. This is for Port of Spain. See, there is not that pattern of NOxes, and there is no ammonia. There is some SO2 here, which may probably be because that was a big traffic jam one day and there was a lot of traffic, and idling cars are what causes a lot of pollutants to build up. There's something you would have noticed. The carbon dioxide levels usually stable in most environments between 300, 450. That's usual ambient levels. Carbon monoxide, which are the grayish lines, well, the white ones here, they tend to be a result of traffic and combustion processes. And the levels of methane, which is this blue line, tend to be kind of stable in all the environments tested. So there's a residual amount of methane in all the profiles. Industrial. Okay, well, there's one more I should point out. Sorry, go back here. I don't know if you'd see this, but this is some kind of event that was picked up both at Waterloo and at San Fernando that involves methanol and some ammonia and some NOxes. So it's something to look into. I have no idea what happened there. The industrial profile, you see the same pattern of NOxes and SOxes as you saw at the rural station. And so that leads me to think that it has something to do with industrial processes going on, and it indicates the significance of the industrial input to NOxes and SOxes, the air contaminants from the industrial source. This is a picture of the EMA's historical data for last year on the same period that I was sampling, and you'll see this purple color that didn't show up in any of my apologies. That didn't show up in any of my slides. This is ozone, and that's because I can't sample ozone. It doesn't see it. The Fourier transform technology would see things that absorb in the IR. Ozone does not, so it will not be picked up. It picked up a lot of chemicals, but it can't pick up everything. It would have been great if I could have included ozone as one of the criteria pollutants in my sampling regime, but this project was very expensive, and it would just have added to the expense, and I could do only what I could have managed. The criteria pollutants alone, you see, you do get some information from it, but it's not the only thing you need to measure, because there are lots of other things that affect air quality. The deliverables from this project are directly linked to the objectives. Okay, I expect that at the end of this, that I would be working with TT Met Office, with the EMA, with the UTT to continue its air pollution work, with external partners such as the EPA, the University of Kent probably to investigate if we can use satellite imagery as a remotely sensing air pollution levels, and have a ready network of stakeholders within which we can take air pollution and monitoring in Trinidad and Tobago forward. The second thing is that at the very least, my thesis would produce a baseline condition. This is what the air pollution profiles look like for different areas. It's a basis from which we can start air pollution management and monitoring, and it also can be used as a reference for environmental impact assessments, because a lot of times environmental impact assessments seem to just take one-off data. And I remember being a consultant and having a client who would only let us sample when rain fell, because precipitation rains out contaminants, therefore reducing the levels that are there. And it's a snapshot. When you do an EA, it's a snapshot. You want to get as accurate as possible, but it's not, you have to do the best you can, because you have to work with other parties. This is an academic undertaking, so there will be scientific publications out of it. UTT has spent a lot of money and a lot of effort in developing the expertise and building the infrastructure to do air pollution monitoring work. I would expect that this would not be something that would be left derelict after I am no longer a PhD student here. It is a resource that I hope entities that have to do air pollution monitoring, you don't have to repeat or try to build back something that's already existing, that you work with what's available. You use the universities as a place to get relatively affordable scientific data. that is of a high quality. It's also good public relations for the university and for PPTT, because many years ago, several years ago, when they decided to fund this project, we didn't have air pollution rules. We now do, so it's quite timely that this is going to be ready and available for building air pollution monitoring strategies for Trinidad in the next year or so, over the next year or so. This project was not without its challenges. The sampling equipment for air pollution was very expensive. It was also very precise and very sensitive, and it was also possible that it can break down. The technology is new. There was a lot to learn in a short space of time, so there was training that was needed to do. There was a late start in the project because there were some delays in purchasing the sampling equipment. I'm still waiting on permission from Plebdeco to sample on the industrial estate. It was a lengthy process, a lot of harassing, and it still didn't happen, and the request is still there. So that's why I'm sampling adjacent to the estate, on the property adjacent to the estate, and not on the estate itself. And the other thing is that it's anticipated that work on this research will go on after the PhD is submitted, because the whole objective is to use this work for national development, to use it as a basis to build a air pollution management strategy for Trinidad and Tobago, or at least to inform policy and to inform, to have better environmental impact assessments. These are some of the references that I used for this project. There were two landmark studies that were done for air pollution work that I know of. One of them is the Harvard Six Cities study, and the other one was a Cancer Society study, which basically traced a cohort of people over 6 cities to see some were more polluted, some were less polluted, and used particulate levels at the different cities to kind of establish how polluted the cities were, and traced with consideration for all the confounding factors, how fast did people died, what they were afflicted with, and it was found that yes, particulate levels were linked to the levels of death, particularly due to a respiratory disease for the cohort study, and for the Utah study, the Cancer Society study, particulate levels, which were incidentally, most of the levels during the study averaged 50 to 54 micrograms, which is less than the air pollution standards. But there were measurable, discernible increases in mortality in lung cancer and cardiovascular disease. So most of the effects of air pollution are chronic, but it has been shown to have acute effects as well.